Namaste everyone. This is Dr. Ayesha Butalia. Today we are going to discuss about the reinforcement learning related to machine learning and data mining models. Basically, reinforcement based machine learning model is an experience based model defined through our data mining techniques. This part 8 is basically it shows that there are previous lectures related to machine learning and data mining. Coming from those one by one, now we are in a position to discuss the machine learning in advance. So the outline of the lecture of today's presentation is what is reinforcement learning, how it is different from supervised learning, concept-based model. We will be discussing about context and concept-based model and example using facial expression and sentiment-based systems, and differentiating the quantitative and the qualitative analysis with respect to descriptive heuristic model and the predictive model. So let's start. We are going to discuss this topic on my research paper, which was presented long back, maybe a few years ago. Okay, I'll give you the description in the link box about the paper. But presently, since it's a research paper, a lot of things have been given in quite brief, but it will be interestingly to note the highlights and cover the topic in a short duration. So machine learning, to have a successful functional implementation, requires interdisciplinary approach. This is why, because the expectation from intelligent systems are increasing day by day. What an intelligent system was supposed to do a decade ago is now expected from an ordinary system. Whether it's a washing machine or a healthcare system, we expect it to be more and more intelligent and demonstrative the behavior while solving complex as well as day-to-day problems. The applications are not limited to a particular domain and are literally distributed across all domains. Hence, domain-specific intelligence is fine, but the user has become demanding, and a true intelligent and problem-solving system, irrespective of domains, have become a necessary goal. So that's the entire approach why we are going on to the advanced learning system. And that's why we will be discussing about the reinforcement learning today. We want the systems to drive cars, play games, train players, retrieve information, and help even complex medical diagnosis. All these applications are beyond the scope of isolated systems and traditional pre-programming learning. So, as we go ahead, knowledge data discovery, KDD, is based on extraction of knowledge from data through information and through intelligence. This we have already discussed the hierarchy in our previous lectures. Machine learning is a part of artificial intelligence, which in simple words is the intelligence related to machine computers, being more specific. Since computers understand only mathematics, they have to be made intelligently artificially through mathematics. So that's the entire purpose behind machine learning. A machine doesn't have emotions, but learning fed to the system can even generate that through machine learning system. Today, the example which we are going to see is about the sentiments, okay, based learning through our system. So definitely by through we will be designing the machine learning system as humans, intelligently like humans. Data mining, it is very, very related to machine learning. Obviously, we have discussed this in previous lectures. So since it's the topic of machine learning and reinforcement, data mining, obviously, it has a wide scope of applications using algorithms for extracting information from large set of data. Because rightly we said that we are going to extract knowledge from data. So this is nothing but extracting information from large sets of data and retrieved in a better form so that intelligence retrieves the modified version through our BM algorithms, maybe on small sets or as increasingly on the big data. So our machine learning research has making great projects in many directions, majorly on the improvement of classification accuracy by learning the assemblers of classifiers. Okay, we need to identify what are our classifiers. For example, if we are designing a sentiment-based system based on facial expressions, so our classifiers would be uh, uh, the model which determines the facial expressions. For example, the position of the lips, whether they are broadened or contracted, the position of the okay eyebrows, whether they are contracted or expanded, right? Similarly, what is the position of the eyes? Okay, whether it is closed, it is weeping, a person is crying, and so on. So, what are the classifiers? Then method of class scaling up supervised learning algorithms. Reinforcement learning is one of the directions, and learning of complex stochastic models. Okay, so machine learning is basically a field of science as to program systems in order to automate them through learning and training, maybe with experience, with number of samples, with time, etc., as human does, but due to its high computational power, the results may extremely high and unexpected, getting through the drawback which humans have. So the main point to highlight here is when experience comes, then reinforcement learning comes into picture majorly. So basically reinforcement learning is an area of machine learning concerned with how software agents ought to have taken in an environment in order to maximize the notion of cumulative reward. Okay, so reinforcement learning is one of the three basic machine learning paradigms alongside supervised learning and unsupervised learning. So in our previous lecture where we had differentiated different techniques and algorithms, we had said about the prediction algorithms, okay, in which we have classification, whereas in descriptive models, we had clustering. Okay, so the classification is more about the supervised learning, whereas clustering is more about the unsupervised learning. We can also talk about the quantitative approach, which is our prediction model, where we have some history through which we uh, try to analyze the outcome. Whereas our descriptive model is more like a qualitative approach, okay, in which we try to design the system for using unsupervised learning mode. But there is another system called as reinforcement type of learning, which is the learning through our experience. So in simple words, this complicated technology can be classified simply that the reinforcement learning is one of the three basic machine learning paradigms, that is supervised learning, unsupervised learning, and the reinforcement learning. Of course, the semi-supervised learning is a combination of supervised and unsupervised, but it's not a different paradigm altogether. So going through the components of a machine learning, a general, a network, a framework architecture. Here you can see that we have got a concept-based development, okay, and we have got a context-based development, right? So whenever we try to propose the methods, right, we are going to incorporate the history, that is the empirical data, the experience, and the case studies and examples. Also, the logical reasoning. So when we incorporate all the four, okay, that's called as the concept development, because the concept which we have defined has come from the previous history, from our experience, from the examples we have, and from the some logical reasoning like if then else, if this happened then this happened, or if this will happen, this will happen. So this is called as logical reasoning. But apart from that, we have something called as the context based learning. And then which generally context-based learning is used specially in terms of examples. So it's a two-way hierarchy. From the examples, we get the context-based learning. And once we decide the context-based model, then we can incorporate through our examples also to the system in terms of learning, right? So this is our prediction model. This is our description model, okay? And this is our reinforcement learning model. So all three paradigms come together to have a concept model. We have a logic reasoning, which obviously it will come as per the time, okay, where we decide that this happened more of a hard computing terms. Whereas soft computing terms means the results are more towards the approximation. So mostly the soft computing applications are designed using all the three paradigms, right? Because we need to have, as discussed in our previous lectures, we need to first uh, train the system you by 80-20 rule on 20% of the data sets, and then test the system on the 80% of the data set. So that 20% of the training would be depending upon concept model. But what is context? In terms of, say, sentiments, right? If we have tears in the eyes, so tears can be eyes in terms of happiness also, in terms of sadness also, maybe some past relevant uh, emotions it come up, some history it comes up, okay? So, or maybe there is burning in the eyes, right? Or maybe it's artificially plucked, what actors do for crime. So it can be n number of things where context depends. For example, if the person has fainted, okay, and he's lying down, so it can be that the person is sleeping, it can be that the person has fainted, it can be that the person is no more. So it depends upon what is the context, right? So even context based learning has to be evaluated. So we have designed a system which we will take in one of the other research papers, where the uh, context-based learning approach generally is through our examples of our previous experience just before and what is going to be after. But the before can be just immediate or maybe 1 year ago. For example, a person always reacts on a situation depending upon what has happened in the past, maybe in his childhood, or maybe just happened 6 months ago, or maybe 6 days back, or maybe 6 hours back. And based on them, our decision outcome or our classification or our clustering depends. Now, this RS here is the rough set theory, which is one of the predictive model used for data mining. ANN is the artificial neural networks, which we have used for even the descriptive approach model, a heuristic model, and also for a reinforcement model. Because when we had discussed in our neural network as one of the techniques for machine learning and data mining, we had seen that we have got a feed forward and back also technique. So reinforcement learning is once you go ahead, we experience something and then we go back and rectify it. So that's all about the ANN. So incorporating the context-based learning, the descriptive model, the predictive model approach, okay, combining them, and then we decide our rules and strategies to classify our data and the outcome which is expected. So the concept can be developed using different components as discussed, say past history or background knowledge and experience, case studies, examples, logical reasoning, etc. There are different strategies and statistical methods. Any one example is highlighted in figure as far as the sentiment-based system is concerned. They led to finally the decision rules, classification, clustering, etc. They can be used depending again on the knowledge to be discovered, the dimension to which we see at. That's the context-based learning. The methods mentioned are one of the highly efficient. For example, rough sets alone can classify, cluster, and come to the conclusion depending upon type of decision attribute we select, which is again domain specific. We have a separate lecture on rough set theory. It's a very strong machine learning and data mining technique. Okay, as said that for classification, that is data mining, and for machine learning, that is clustering. In one of the lectures, we had discussed about that the prediction model is used more for data mining and descriptive model more for machine learning. And as said right now, the classification is one of the predictive model and clustering is one of the descriptive model. So rough set theory is a single mathematical model which is used for both the uh, type of models and very good to handle soft computing applications, say uncertainty and precision in the data. The same example of sentiment analysis using rough set theory in detail is explained in, we will give in the description box about that YouTube video as well. So more about reinforcement learning. So basically, reinforcement learning is also a part of deep learning method that helps you to maximize some portion of the cumulative reward. For example, what we had mentioned here about the neural network. So this neural network learning method helps you to learn how to attain a complex objective or maximize a specific dimension over many steps. So I hope this lecture would be useful for you to differentiate what is a concept development model, what is a context-based learning, and how the different three paradigms, supervised, unsupervised, and reinforcement learning is incorporated. Thank you for your patience listening. If you have any doubts, you can write me mail as given below, or you can even post your query. I would be happy to solve your doubts.